So this is what happens. Okay, so you have a box 1 by 1 by 1 meter. Okay, and how much energy do you need to change a unit volume of seawater by 1 degree compared with it to air? So what comes into the play here is, in order to work this out, you need to know what is the density of the substance. And the density is the weight per unit volume. Okay, so how much does 1 cubic meter weigh? Okay, for seawater it's around 1026 kilograms, and for air is much lighter, it's only 1.26 kilograms. Okay, if you multiply now the specific heat capacity with the density, if you multiply these two things, you get the answer. Okay, and for seawater, you need about 4 million joules to change the temperature of 1 unit volume, okay, by 1 degree. And for air, you only need 1,280 joules. So it's a huge difference, and the difference is about 3,100 times. So you need about 3,100 times more energy to heat up a volume unit of seawater compared with the same volume unit of air. And so for this comparison, it makes sense that actually to think about how the atmosphere interacts with the ocean, because you could think of a surface area of 1 square meter, okay, and then you have a volume of air sitting above it, and you have a volume of seawater sitting below it. Okay, and so now you can transfer heat from the sea into the atmosphere, or the other way around, and you can cause a temperature change. Okay, and we can compare that. Okay, what you also can do is you can compare the response time. So how fast do you heat up the surface mix layer of the ocean compared to soil on land? Okay, and this is now summarized on the next slide.